Today, we're witnessing something extraordinary. This is a visualization of what the crew aboard the Artemis II mission will actually see as they travel around the far side of the moon. What you're looking at is not just animation. It's based on a real trajectory the spacecraft will follow after translunar injection, the critical burn that sends Orion from Earth orbit toward the moon. The journey begins at around 1800 hours Universal Time Coordinated and spans nearly 8 hours, covering one of the most important phases of the mission, when the crew conducts scheduled scientific observations. As the spacecraft moves deeper into space, something remarkable happens. Earth slowly fades into the distance, while the moon grows larger and more dominant in the window. This spacecraft, known as Orion and named Integrity, is carrying 4 astronauts farther than any human has traveled in over 50 years. At its closest point to the moon, what we call pericynthion or PC, the spacecraft will pass at an altitude of approximately 6,545 kilometers above the lunar surface. That might sound far, but in spaceflight terms, this is a carefully chosen trajectory. Unlike landing missions, Artemis II is designed as a free return trajectory. This means the spacecraft uses the moon's gravity to bend its path, slingshotting around the far side and naturally guiding it back toward Earth. This trajectory is not just efficient, it's also incredibly safe. In fact, a similar path was used during the Apollo 13 mission, when an onboard explosion forced the crew to abort their landing and rely on the moon's gravity to return home. But there's a key difference. Apollo 13 passed much closer to the moon, just about 251 kilometers above the surface. Artemis II, on the other hand, maintains a much higher altitude, allowing for a completely different visual experience. From this vantage point, the crew will be able to see the entire disk of the moon at once. Imagine holding a basketball at arm's length. That's roughly how the moon will appear through the spacecraft window. It's a perspective no human has experienced in over half a century. As Orion moves behind the moon, communication with Earth will temporarily be lost. This is known as loss of signal, and it's one of the most intense moments of the mission. For a brief period, the crew will be completely isolated on the far side of the moon, with no direct contact with Earth. Yet everything during this phase is precisely planned. The visualization you're watching was actually used by the Artemis II lunar science team to design observation schedules and mission operations. Every movement, every angle, every second has been carefully calculated. At the same time, the spacecraft continues its journey to the farthest point from Earth. At its maximum distance, the crew will be approximately 406,740 kilometers away from our planet. That's farther than any human has ever traveled, breaking a record held since the Apollo era. To put that into perspective, even the Apollo 17 mission, the last time humans visited the moon, did not reach this distance. This is humanity pushing deeper into space once again. And as the spacecraft swings around the moon, something incredible happens. Earth reappears, a small blue sphere rising above the lunar horizon. This moment, often called Earthrise, is one of the most powerful visuals in space exploration. It reminds us just how small and fragile our home planet really is. From an engineering perspective, everything you see here is the result of precise orbital mechanics. The trajectory, the timing, the speed, all governed by gravity and motion. No extra fuel is needed to return home once the spacecraft is on this path. That's the beauty of a free return trajectory. It's elegant, efficient, and reliable. This mission is not just about going to the moon. It's about proving that we can safely send humans deeper into space and bring them back. It's about testing systems, validating technologies, and preparing for the next giant leap. Future missions that will land astronauts on the lunar surface and eventually take humans to Mars. For the crew aboard Orion, this journey will be historic. For us watching from Earth, it's a glimpse into the future of human exploration, a future where deep space is no longer out of reach. And this is just the beginning of a new era.